Welcome to my talk, Libraries, Libraries, Libraries. I'm Andre von Houck, and you can find my libraries on GitHub at GitHub/treeform. What is the biggest problem in the software industry today? Many things come to mind, but for me, there's a clear one problem that I see repeated everywhere. For me, it is over-reliance on libraries without understanding what they do. And I see this everywhere, and I think it permeates the industry at such high degree that many people don't even think about this or don't question it. I want to bring this to light. I think it's very common to download a repo and see hundreds or even thousands of libraries pulled automatically with tools like npm install or pip install or whatever the package manager is in your language. For example, a little bit ago, I was pulled into a project to look into this new project that just got started, and I wanted to check it out and see how it's going. It's a JavaScript project, so I download npm and install GitHub, and it brings in 800 libraries. And this is a new project that does relatively little. And it's like 800? Like, what's going on here? I just don't get it. I think like, how this thing does almost nothing. And 800 libraries is just insane. Another example, I was working on a different project. This is for Python, and I had to use Python pip and install Anaconda. And anyone who's ever done this knows it's like a lot of a very complicated thing. And then I get low hard drive space, and I'm like, what's going on? And I looked into it. It's 100 gigabytes of different libraries, and I'm like, what's going on here? This can't be right. There's probably a lot of images or like zip files or something in there. No, turns out it's all just compiled C++ code. And I'm like, wow, how is this possible? Like, this is a simple thing that I'm trying to do, and it's like 10 gigabytes of compiled code? Insane. What is the result of this all? I see this again and again. The result of this is that everything is very fragile. We have built a system on a house of cards. A fragile system where no one fully understands all the dependencies. If something breaks, no one knows how to fix it. If something isn't working right, no one knows where it's coming from. I see this again and again at talking to people. It seems like everyone is just like, well, that's how stuff are. Programming is like this incredibly hard thing where it's like nothing can like be understood or replicated. It's so weird to me talking to people like this. It is very hard to do any kind of debugging. When something breaks, it's nearly impossible to know where to start debugging. It's like, why? Why have we created this system for ourselves? I don't understand. A good example of this like left pad in Node.js. It's a stories all this time. It's almost attained a mythical status at this point, this left pad. So one small library removal broke thousands of projects. And it's like, oh, we should have, and the conversations around it were like, oh, we should have better like library governance. Maybe stuff like that should exist forever. Like the libraries should be mutable once you upload it, like no one can delete it. And then it's like, well, maybe we should like find a better left pad and like then reputation. But for me, it's like, why even use a library for left pad? Why even use a library for most things? It's like, why we've created this thing for ourselves. I don't get it. Left pad is very simple. It just like moves, a string, from one place to the other. It's like, why? Like, I just don't get what is going on and why other people just not up in arms about this problem. As languages like Nim gets more popular, it naturally accumulates more libraries. And I think that's actually a good thing. More libraries get written. It is easier, to some extent, to write software, This is like the good side. More features, a richer ecosystem, more options for developers. When I just want to try out something really quick in Nim, it's nice if there exists just a library I can download, play around with, and not think about it. But it also has like a bad side. I think this is where like big languages like Python or JavaScript have gotten, is that the libraries are just so numerous, and you basically like the ecosystem basically pushes us for you to use libraries and nothing else. Like writing things from scratch just doesn't appeal to people. Someone that's using Python, they're just like, oh, there's so many libraries out there. I'll just use one and I'll just move on with my day. But then using so many libraries increases the bugs, increases more dependencies, and even like a larger attack surfaces if you're writing, websites or user-facing stuff. It's like just weird. It's not good, and no one talks about the bad side of having an overabundance of libraries, an ecosystem so large that just writing something new isn't worth it. Huge problem with using a bunch of libraries is as many developers don't know what they're using, like what the dependency tree even is. It's interesting that when I used the npm, it told me, well, you've just installed 800 libraries. That was very useful to know. Pip, I don't think it does that, right? It's like you don't even know what's going on. And, you install a project, you add a library, you add another one, you bring in someone new. You don't know what the dependency tree is. And when I ask, different developers, what are they using? They might tell, one or two libraries that they're, dependent on. But their projects, again, might have 800 libraries. They don't even know what's going on there. I take a different approach with Nim. I use Nim extensively at work, and I use a lot of Nim in my day-to-day and my hobbies. I love Nim as a language, and I take a different approach. And I kind of like that it doesn't have the abundance of libraries that JavaScript, Python, Rust, C++, C, all those languages, they have such a big abundance. But I like that in Nim, I'm almost forced sometimes to write something new. And I like it. I don't use many external libraries in my project. Instead, I use other libraries as inspiration and learn from their solutions. But in the end, I usually write my own. And I can use libraries. I usually use libraries in a bunch of different languages. Languages that are more, I think, feel similar to Nim and looks like, for instance, JavaScript or Python rather than C or C++ libraries. But I look at them for inspiration. I want to see how they've done things, the solution they solve. I like reading other libraries' code. I'm very thankful that they exist and that they're open source. But I generally don't use the libraries. I take their best parts, their best ideas, but I re-implement them. I create my own solution. I think there's a lot of benefits to rewriting everything. And yeah, people don't talk about them as much. For me, I use the purpose-built libraries tailored for my specific project needs. This, generally, the libraries are not as hard to write. You might look, oh, I need this big library to do this thing. But a lot of times the library solves so many different things that you don't even need. You can just take that small part and adapt it for your use case and kind of rewrite it. Use the ideas and inspiration of that library, but still write your own code. A purpose-built code specifically for the use case that you're trying to solve right now. This generates leaner, much smaller code footprint, faster code because you don't have all these other things getting in the way. But the most important thing is that I fully control and understand the code. I think that's the huge benefits to writing your own libraries. Yes, I would say it would take more time up front, and this is what people say, I don't have this time to write everything, right? But I feel like it saves me countless of hours down the road. When something breaks, I know exactly where to look. I think this is very, very important point that this is overlooked. When there's a bug, a lot of times I actually know where it is. Like, I don't have to even debug it. Oh yeah, this bug, I know it's probably because I did this thing, you know. I didn't account for that use case when I wrote the library, so obviously when you do this, it will break. I usually know exactly where to go, exactly where to fix it. Like, it is way, way different when working on a large project with a lot of dependency libraries. A lot of stuff like breaks and you're like, well, I don't know, here at Dragons the code is like, 20 stack traces deep. It's like, I do not know where it is, like, why is it doing this, why does it go there, why everything is so generic, it's very hard to click from interface to class. It's like, no, none of that happens when you write your own libraries. None of that happens when you actually know how everything works, because everything can kind of fit into your brain. Everything is confined. It's everything. Basically, you have a mental model of your entire project if you wrote all your own libraries. Let's look at some examples. So Vmath is a vector math library I wrote. It's a vector math library to do graphical things. It includes things as 2D vectors, 3D vectors, 4x4 matrices that are used in 3D programming, trigonometric and angular functions. It is very GLSL inspired, so if you see some GLSL code that is used in shaders, you can probably adapt it to use Vmath without much fuss, like the names are practically identical. I could have used an existing math libraries, and they actually existed for Nim. There's actually several quite good, I would say, vector libraries. Like, I wouldn't mind using them, but I wanted to learn how to write my own, because I'm going to be spending a lot of time with vector math, making games and other graphical things. I wanted to truly understand how everything works at the lowest level. And writing the library that you're going to use is an excellent way to do this. The result of writing this library, I gained a deep insight into vector math, and it produced faster, more efficient library to tailor my needs. An example here is, actually you can do 3 different vector representations in Nim for a simple 3D float vector, right? So you have 3 components, x, y, and z. You could just create an object that has x, y, and z, and then just a float 32, very common in graphics programming. You could also do a different thing. You can create an array of 3 floats, a little less common, maybe more common for something like C, where you would do that if like you just say, hey, I want an array of 3 floats. It's more general if you have like array of 2 floats, and then you can have array of 3 floats, and you can have a function that are general and work on them. So there's some advantage to that. You could also do this weird thing where you have an object and it has an array of 3 floats. But because I wrote my own vector library, I could choose this. This was very easy. If I was going to run this experiment with a library someone else wrote, this would be incredibly hard. But what I did is I benchmarked the 3 representations. So first one, I have a benchmarking suite for this thing, so it runs in 74 milliseconds. So that's great. Then I benchmarked this array stuff, and it actually was slower. And someone was saying, no, it's supposed to be faster. But like, why was it slower? Interesting. And then it's probably because of weird like aliasing rules in C, because Nim does compile to C eventually. Yeah, to me they sound like the exact same thing. But then something interesting happened. When I created object array of 3 floats, it was actually faster than using the XYZ stuff. And I was like, why? I couldn't really explain it. I, of course, made my library, you can pick the 3 different representation, depends like what you like, but it doesn't come up because the API that I give to people is exact same. But internally, like, why not use a faster representation? Why not use an object array instead of, the object or the array? The object array is just faster. I can't really explain it. I think it's all to do with C aliasing rules and how the copy rules works for arrays and objects. But yeah, this was just easier and faster, which I found surprising. But these are the kind of things you can do when you write your own library. I'm using this for 3D vectors, which is like useful in games and other graphic applications where the performance is paramount. So shaving, 2 milliseconds here from a library that you use a lot is amazing, and I think that worked out great. Completely transparent, but yeah, just save those things. Let's look at another example that I wrote. So Debby is a database ORM layer for Nim. So there are several ORM libraries for Nim, and then they're great, and it's cool. But because the ORM, I feel like, is so personal, if you're writing any kind of decently sized web app, you're going to be using a database. And ORM code is going to be everywhere. And I really, really need to know how the ORM works. It impacts performance a lot, right? And it impacts also how you write your code a lot, and how the error handling and how transactions, like, there's so many little bits that need to be gotten right. And for this core of my web app, I didn't want to trust someone else to do that work. I wanted to really understand how to do it. I felt like I've used many different ORMs in the past, and I've always disliked something about them. I think I have like a feel of how I want ORM to work. So this is what I did. I wrote it. Instead of using bloated libraries, I built a simple, flexible ORM, and it actually only took me a few days to do. And I was very happy, because it is completely tailored to my needs. It doesn't try to solve everything for everyone. It just tries to solve things for me very well in the way I would solve them. So one thing I did is I bound directly to the C API of the popular databases. Most, like, SQLite has, the libSQLite, the libMySQL, and the libPostgres. So yeah, I just bound to those libraries directly over using some sort of wrapper. The C APIs are quite simple and quite easy to work with. Yes, there's a wire protocol for MySQL and Postgres. There is. I decided not to go that route, but that could be another fine way to do it if I really wanted to. But I just bound to the libraries directly. It was very kind of not that hard, and I think in the end I learned a bunch of cool things, a bunch of cool differences between the three different backends, and I thought it was very interesting. Because I wrote it, I could add custom features that no other ORMs would support. So that's what I did. This was very, cool for me. And this is what I recommend for people to do. Like, if you're writing a web app and you want it to be good and performant, don't use Debby directly. Go look how I wrote Debby and maybe adapt it for your own use case so that you can truly understand the relationship between your web app and your database. One of the examples that I did for SQLite that I thought was kind of cool, the SQLite claims it is faster than the file system. So yeah, I put that to the test. So there is an API where you can pass basically binary data directly for reading and writing, and it is exceptionally fast. MySQL and Postgres doesn't have that feature. If you pass it pass it binary, large binary strings, it's not very good at handling them, and it has to be encoded and decoded. But not so for SQLite. Cool feature, and it's something I would not have known if I didn't take this approach. Next, another cool library that I wrote is Boxy. It's a 2D GPU rendering with a tiling atlas. I'll explain what that is, but it is built on some of my other libraries. It uses OpenGL. It uses Windy, which is a windowing library that also was written completely custom. It uses a dynamic asset. So the cool thing about Boxy is that you can add images and remove images like everywhere. It's like very, very good for that. The same thing, it's like good for text because you could have large swaths of text to do the exact same thing. It supports other cool effects like blurs and shadows, something that you will find like in a modern UI system. So yeah, it's a very good foundation. Existing libraries just didn't offer what I needed, especially the atlasing system. I thought was very good. It paged like this image stylers. It had a bunch of layer effects. The cool thing is that Boxy is streamlined exactly for my needs. I could have used a complex or a bulky alternative, but this is not where I am. And this is, I think, using that is, again, one of the biggest problems in computer, in the computer industry. This is the cool thing about the Boxy atlas, is that first, when the atlas it creates, it creates a single white color tile to draw it with any color, because you can tint it to be any color. And then whenever you upload images, it actually takes the image and breaks it down on little tiles, usually 32 by 32 pixel tiles, and it inserts them into this atlas. This way, it is very easy to add or remove images into this thing because there's no waste. There's no a bunch of dead space. In fact, it goes even further. If the image that you've added and the tile is fully transparent, it doesn't need to be added. In fact, it doesn't even need to be drawn, which I think is really cool. And if the tile that you added is actually a single color tile, again, there's no need to store it. You can just store that, it will just use that first original tile. The same thing with mipmaps is also pretty cool, because the mipmaps are also stored in the system, because you can no longer use the normal GPU mipmaps if you go with the atlas. You have to basically replicate the mip mapping. And it's very cool because new additions just get to the end of the atlas. It's like very easy. There is no wasted space. All the space in this atlas is like very, very compact, and it stays compact when you add and remove images. Something like that just didn't exist. Like, I would not have gotten to this level of understanding and to this level of sophistication if I just used like off-the-shelf library, like, I don't know, SDL or ArrayLib or something. They're probably excellent libraries, and there's still a bunch of information that I could learn from them. But I think I want to learn it in this like other method, where I learn the stuff, and then I only bring the stuff that I truly need and truly understand. I don't think all libraries are bad. Like, I'm saying, hey, I don't say like never use libraries, always rewrite everything. No, I'm not going that. Like, but I think like we are so far down the direction that whenever you have a problem, find a library to solve it. We're so down that path that we need to swing the pendulum the other way. Like, do rewrite stuff. Do use your own stuff. Do more of these things. Don't just depend on libraries because they're there. I think you need to read the full source of a library before using them. I think that's like a very good rule. If you're going to use a library, I would git clone it. I would go through the source. I would try to understand it, that everything there is like as it seems. I would see how big it is. I would see how many things it's like trying to solve, how general it is. Also, you can tell a lot of the quality of the code by just like looking at how the code is written. If the code has no tests, if the code is like, has no benchmarks, like, it's like, yeah, what are the guys were doing? Like, is this even worth it? If the formatting is all over the place, hey, did these guys even like run a formatter? Like, if there's like no comments and everything is just like weird and the names are single character, you might go, maybe I don't actually want to use this library because it just looks kind of bad. Right? But if the library looks good and like to your definition of good, you're like, oh yeah, I actually like this and I like using it, and so just using it. So I highly, like, one of my rules is read the source code. You don't have to like fully understand it, but at least like scan through it. Like, you owe that to yourself. Another big rule that I follow is don't put big libraries on critical path of your product. If your product is related on something, don't put like a big library. It's like, yeah, I'm like my entire like project is based around this library. No, don't do that. If your project, like, you should understand exactly what's going on. If your product or project depends on something, you should understand it. In that case, you should probably write it the way I said. Use other libraries for inspiration, and then write a minimal version of those specifically for your product or project. Right? Don't rely on something big in your critical path. Just don't. But if the library is not in your critical path, if it's like something small, something on the side, something as a tool, yeah, put libraries there. If you're experimenting with something and just want to get something on screen or something working, yeah, by all means, use a library. It's a great use case. Just don't build your entire product around it, right? Because when something goes wrong with those libraries at, I don't know, 12 a.m. at night, right, you want to know what's going on. What, like, you don't want to wake up, during the night to go and fix something or like figure something out that I didn't even cause. That's like the worst. Yeah, don't put big libraries in critical path. I think that's very important. Another big thing, especially in the case of Nim, the language, I think rewriting libraries keeps ecosystem fresh. I think in older languages like C or C++, there's these libraries that's been around for, I don't know, decades. They've been written for something like Windows XP or something, right? It's like the computers have changed, the ideas around things have changed, right? It's like, yeah, like we gotta, I think, reinvent things to keep things fresh. And this is why I kind of like the Nim language over the alternatives, is I think the entire ecosystem isn't like fossilized and stuff still can be written. New things can still be discovered and new things can be done freshly. Like I think for building functionality from scratch ensures continuous progress and modernization. I think it like allows you to cut away the bloat and streamline it for your project and specific needs. Again, if your library is critical to your project, you should really, really know how it works. If it's not critical, using off-the-shelf library is fine. And I think there's another rule: never use more than 100 libraries in a single project. This is just like a lot. Like you would never know how anything like fits together if you have that many libraries. Again, don't build on a house of cards. Rewrite the libraries that you depend on most. That's like the big central thesis of the stock. Write your own libraries more often. I wish more people wrote more libraries and made them open source so I can not use them, but read their source and learn from them. I think it's great. Your code will have less bugs and it will be faster to add new features if you continuously rewrite the libraries, if you continuously stay fresh, and if the whole ecosystem in Nim will continuously write libraries and stay fresh. I think that's really important. Thank you. This has been my talk. Libraries, libraries, libraries. Have a good one. Maybe ask a question in chat.